Hiya! In today's video we are going to be going through abstract classes and interfaces. Now, things that we should already know at this stage. We should already know a little bit about objects. We should already know a little bit about inheritance, just to make our lives a little bit easier. So let's have a little look at this class diagram, and then we can get cracking. So what I've got quite a few things going on in this class diagram. We're going to attempt certain parts of it and see how we get on. The first part we're going to try and attempt is the device class. Now, just a little quick explanation. This device class, we're going to implement it. First of all, we're going to implement it as a concrete class. And then we're going to turn it into an abstract class. A concrete class is where you can make an instance of it, so you can create an object. And an abstract class, you can't create an object of it. So we're gonna be going through that. I'll show you how to do that shortly. Past that, we've got, so this is our superclass. We've got two subclasses going on. So laptop is our subclass and mobile phone is another subclass. With Java, you can only do single inheritance. So for example, this mobile phone class can only inherit from one other class. I can't do multiple other classes that I can inherit stuff from. And that's some languages you can do multiple inheritance, some you can't. In Java you can't. So we already know how to do a little bit of inheritance. We're going to be starting there and then changing it into using an abstract class, and we'll talk about how to do that and why to do that. And then after we've done that, we're going to be looking at interfaces. So this interfaces, we've got these two down the bottom. We've got recyclable and we've got chargeable repair. Those are my two interfaces, and we're going to implement those and then talk about why you would choose to do that or why you would choose to not do that. Okay, so we'll start off by making this device class. Now, again, I'm going to start off by making it just a regular class, and then I'm going to show you kind of how to make an object of it. So we're going to be recapping some stuff as we go through, and we'll see how we get on. All right, okay. So let's get cracking. Now, I've made a project. My project is called Device Repair, and I've got nothing in it so far. All I've done is just delete the comments. So there's nothing else in there, and I'm going to start getting started by making a new class. Now, my first class that I'm going to make is the device class. So if I come up here, click New, Java class, and then device. All right. So we should already know how to do that part already. That's just creating us a new class. All right. Now again, just going back to our class diagram. This is the one that we're making. All right. So we're making this particular class diagram, this particular class at the moment. We're making the device class. We've got some variables in here. Now let's just have a double check on if we know how to read these particular variables. Now I've got little hashtag next to them. Little hashtags. That means they're protected variables. Okay. You've got at least 3 different access modifiers. So you've got public, you've got private, and you've got protected. With protected variables, all right, protected variables, you tend to use them in a superclass, and that means that the subclasses can have access to them. All right. So you tend to put them in a superclass. It means that the subclasses, the ones that inherit all of the methods and variables from this class, can have access to them. If it's public, if you set something to be public, see these methods have got little pluses next to them. If you set something to be public, that means that you can access it from everywhere. You can access it from different classes, anywhere you like. If you set something to be private, you can see that we've got private variables with a little minus signs just down in these particular subclasses. A private variable means that you can have access to it only within that class. So this priority variable, I can have access to it only in the mobile phone class. This repair notes variable, I can have access to that in the device class and in the mobile phone class and in the laptop class because they've got access to it, but I can't have access to that, say, in the component class. I can't get access to that because it's protected. If you've got something that is private, again, it's just within the class. Public means you can have access to it wherever you want, and that is not a problem. All right. Okay, so we're going to get cracking on this device class. We're going to start off by making it a concrete class and playing around with it, and then we're going to turn it into an abstract class and then just see if we can spot the differences. All right. Okay, so the first thing I'm going to do is I'm going to cheat. I'm going to just paste some variables in. All right, so I didn't write these in, I just pasted those in. I wrote those earlier, I copied and pasted them. So I've got my protected variables at this stage. So I've got identification code, maker, model, owner, problem description, and repair notes. Now these are all strings. These are all strings. I've put them in as strings. Just a little side note, at any stage, if you do want to pause this video and catch up with me, please do. Because I know I may be going quite quick, so just pause it if you need to, and then catch back up with me. Okay, so at this stage, what I'm going to do is I'm just going to do a few things. So I'm going to insert a constructor. So I'm going to make it do the work for me here. I'm going to select everything and say generate. So that's generated me the constructor. That means that when I create a new device, I have to give it these things to create a new object. All right. So that's like the setup part. When I create a new object, I have to give it these variables, and that will then create me the object. Now, then I'm going to insert my getter method. So these are the methods that allow me to get access to something. So if I have made an object and I want to get access to the owner, I can call, using the object that I've created, .getOwner, and I'm going to show you that shortly. Alright, so this allows me, the get methods allow me to get access to those particular variables. Alright, next ones, insert code, setter method. So these ones allow me to set the variables. So if I've already made a device and then I want to overwrite it with a new, say, owner, I've got .setOwner. So I've got the setOwner method that I can call, and I can do that. Alright, now this at the moment is a concrete class. I know that we've got protected variables in here, but this is a concrete class. That means that I can pop over to, say, this one, and I can do device, and then I'm going to go device with a lowercase equals new device. Oh, if I could spell, that'd be great. Lovely. All right. Now remember I said that when you create a new object, which is a device, you need to give it these particular variables. All right. Otherwise, it's going to say, I don't know what you're talking about. I can't make that. All right. So I'm going to cheat, paste them in, and then change them. So my identification code, this is going to be the identification code for this particular item. So I'm just going to hammer the keyboard for now. Alright, and we're going to go with a string make and model. Let's go with, it is a Chromebook. Alright, owner, me, I am the owner. Problem description, it's a Chromebook, so let's say smashed screen, because I got so annoyed with it, I smashed the screen on it. Oops. Alright. Last little bit that we've got to do is what we're going to do in terms of the description. So we're just going to go order new screen and replace. All right. So at this stage, I have got a device object. All right. So again, this is a concrete class. I can create a new object. I can create a device object, and that is absolutely fine. It has not kicked up any hissy fits. It has not told me that that is not okay. It has not given me any errors at this stage. Okay. If I wanted to then use the methods, I would need to call them by using the name of the object that I've made. So if I wanted to do something like setOwner, and I wanted to change it to be someone else, then I would just need to do .setOwner. I need to use the object that I've created, the name of it that I declared just there. And again, if I've been interested and I've just put something like D, just make sure that you've used that object name consistently just throughout to access it. All right. Okay. Now at this stage in the game, this is not an abstract class. All right, this is just, again, this is a concrete class. I can create an instance of it. My instance of it is just there. That is an instance of the device class. All right, so it's an object. All right, that's called instantiation. All right, so I've created a new instance of it. All right, now what we're going to do, before we make this into an abstract class, all right, I'm going to create one more class. If I come back over here, I'm going to show you. All right, so my next class that I'm going to make is laptop. All right, so I'm going to make the laptop class. Now, I've got a few things in here. Again, this is a subclass, so we're saying it inherits all of the methods and the variables from this superclass. All right, we haven't made it into an abstract class. Even if it is an abstract class, it's still a superclass. All right, so we're going to make this laptop class. Now, first of all, let me just drag that back over to this side. All right, so I'm going to go new Java class. We called it laptop. I'm being a bit interesting with my cases. I've got upper cases here, lower cases there. Psh, we'll deal with that later. Okay. All right, so I've got public class laptop. All right, now at this stage, what I had in my class diagram is that I was going to have a priority. So I'm going to do int. Now I actually said that it was going to be private. All right, so I said I was going to have a priority. I was going to make it private, and that's going to be my method that I'm going to have. Oh, yep, priority. Yep, don't worry about that. That's not used at the moment. We've got a squiggly line there. Now, if we're going to use inheritance, what we need to do is we need to use the word extends here. So we're saying that the laptop class extends the device class. Oh, all right. Now, the second you do that, the second you put that line in, it's going to say, hey, I need a constructor. I don't have a constructor, and I'm supposed to have a constructor to be able to extend this class. So that line will throw you an error message until you give it a constructor. All right, so you just need to give it the constructor. I'm going to cheat do the insert code. Give it the constructor. Notice at this stage that this constructor is slightly different to the one in my device class. All right, so what we've got here is I've got all of these particular things. So I've got strings. I've got 1, 2, 3, 4, 5 strings. In this one, I've got my 5 strings, but I've also got a priority integer. So it's also said that I need to give it a number to start off with for the priority, just to set that. All right. Okay. At that stage, I'm going to pause the laptop one there, and we're going to then go back to the device class. Now we're going to turn this into an abstract class. All right. All right, so with an abstract class, the first change that we need to make is a nice easy one. All right, so the first thing we're going to do is just come up to the top, and we're going to change it from public to abstract. All right, so that's the first thing we're going to do. Now let's talk about what that means, all right? Because this has now done something. It's not throwing any errors. You can see that it's not throwing any errors. I haven't got any red so far, but if I click over to the device repair class, it's going to say, hang on a second, the device is abstract and it cannot be instantiated. It means you can't create an instance of it. You cannot now create an object of the device class. You can't make an instance of it. You can't turn it into an object, all right? That's what an abstract class is. Because if we go back to our little class diagram, it might be that this is an abstract thing. It means that if we think about abstraction, it means that it's removing unnecessary details. Well, at this stage, it's fairly generic. We might want more details for this particular device to become an actual object. So we might have subclasses that implement a bit more detail to it. So we're creating it so that you can't now make an object which is a device, but later on you will be able to make devices which are mobile phones or laptops using the subclasses, but you can't now create a device object. All right, so that's what an abstract class is. It stops you making an object for it. All right, so I'm just going to put little comment up the top. It's a restricted class that cannot be used to create an object. Okay, and that again was my abstract keyword just up the top there. All right. So that is an abstract class. We are going to talk about abstract methods next, because they're slightly different and they're a little bit strange. So with an abstract method, now things that we should already know. We should know what an instance method is. All of these things down here are instance methods. It means that I have to have an object to be able to call those methods. All right, I can't just come over here and go device dot set owner. I can't do something like that. It's going to go, hey, non-static method. All right, you need an instance of it, but we can't make an instance of it. So we can't do that. That is an instance method. It means that I need to have an object to be able to call these methods. So we know those ones already. We're going to be doing an abstract method. All right. The other type of method that we do know already is what's called a virtual method or a static method. So if I come back over to device repair, again, we're just going to ignore the fact that that's got an error at the moment. We already know how to do public, oh, if I could spell that'd be great, public static, and then something like that. That's your static method. We're saying it doesn't return anything. Well, you can have it return something if you want. That is a virtual method, all right? You can call them virtual methods or static methods. With that, it basically means that you don't need to have an object to be able to run it. If something's static, you do not need an instance of it, all right? So what I don't need to do here is I don't need to create a device repair object to call the add method. I mean, I could, but I don't need to. I don't need an object for it. So that's a virtual method. So we already know how to do static methods. I'm going to call them static methods because you're probably more comfortable with that. So we know how to do static methods and we know how to do instance methods, all right? I'm going to show you how to do an abstract method. Now, an abstract method starts with the word abstract, all right? And then I'm just going to write the rest of it. So abstract int, and then I'm going to do get priority rank, and then I'm going to be weird because I'm going to put a colon at the end of it. All right. So this is a bit of a weird thing. Usually the colons mean that you've reached the end of that particular statement, and we have here, and it's not caused me an issue. If I wanted to try and give this a body, it's going to give me an error message. Usually abstract methods cannot have a body. All right. So what I'm doing here is I'm declaring a method that doesn't have any implementation. So the implementation here, let's talk about where that happens, because at the moment this line of code is not doing too much. All right. So what that's saying is that when this particular class gets inherited by a subclass, it forces the subclass to implement this method and define its behavior. So we've got my little laptop class over here. What we're saying is, at the moment this is an abstract method. It means it doesn't have a body. What I'm going to do is I'm going to force the classes that inherit everything from this device class to implement this method. So I'm going to force them to do it. All right? Okay. Now, I'm going to cheekily put two little comments in. All right? Just so we know what we are doing. So this abstract method is going to be a public method when it's inherited by our subclasses. All right. Can only be used in an abstract class, so you can't be whacking an abstract method in any class. It needs to be in an abstract class. Okay. And again, the significant thing is that you do not give it a body. So you only give it a method signature. For example, you would only give it the signature part, nothing inside the curly brackets. You just give it a semicolon. So it doesn't have any implementation. All my other methods have implementation to them. So all of them have got a body. This one doesn't. Okay. All right. Now, let's go back to my laptop class. Now I'm gonna kind of ignore this for a while because we know that this particular thing doesn't work anymore. We know that I can't do that because it's an abstract class. We're going to have some issues in my laptop class currently. All right. Now, the first thing that we've got is it's going to say it's not abstract and does not override abstract method get priority rank in device. Okay. Now, just a little bit of a side note here. If we had started off with nothing in here, all right, maybe we hadn't made this class yet, then we turned this one into an abstract class, and then we made the laptop class, this would be fine. We might find later on that we might get issues with this constructor because I made the constructor and then change the one that I'm inheriting it from. So what I'm going to do is I'm going to just delete the constructor and then put it back in. And I know that seems really strange, but trust me, that's an important step to take. Otherwise, you're gonna have a few issues with things going red for strange reasons, for absolutely strange reasons later on. All right. So again, all I've done is almost refresh it, just get rid of the constructor and put it back in. All right. Now let's talk about this get priority rank class. Now there's two ways of putting this method in. I could do the old-fashioned type it out. So I could do override and then define the actual method underneath, or we could be slightly lazy. Now we like the lazy approach. Alt enter. All right, so what I'm going to do, if we do the alt enter approach, I'm going to do implement all abstract methods. All right, that's going to just chuck it in for me. That's nice and easy, but at the moment that's not giving me the behavior that I would require. It just says throw an exception. All right, we don't want that. That's from a template in NetBeans. So we're going to get rid of that, and we're going to do return and then priority. All right, so we're saying that it has to return a priority here. All right, and that's absolutely fine. That is job done. All right, so it's overriding. Let's talk about that for a second. So this is a subclass of the device class. It's currently overriding the method in the device class called getPriorityRank. It's saying ignore this one and do this one instead. That's what an override is. Technically that's called polymorphism because you're changing the way that the method works, but that's fine. We can come back to polymorphism a little bit later. It's not too stressful. All right. So at this stage, just a little quick recap in terms of where we are. All right, so we have defined the device class. The device class is an abstract class. We have also declared an abstract method that we've implemented in this laptop class. So we have done the abstract class part now. All right, so an abstract class, again, is a way of making sure that people cannot create an instance of a superclass. All right, so again, if we go back to device repair, this totally didn't work. All right, this was not having it at all. It was saying, oh, I don't like this. All right, you can't create an instance of it. But I'm going to cheat slightly. If I made a new laptop device, remember with a laptop device we have to put a priority in, because when we did the constructor we're saying it's got to take a number first. So we're going to go, oh, that priority is 2. All right, and then it would say, let's call it device 2 so we don't get any issues. And then it would go, yep, that is absolutely fine. We are happy with that. The issue we had there is that we already had something called device, by the way. That's why I changed it to device 2. Terrible name, but here we are. So I can create an object or an instance of the subclass, but I cannot create an instance of the superclass, of the abstract class. So again, an abstract class is a way of making it so that people cannot create an instance of that particular class. And again, an abstract method is forcing the subclass to implement the behavior of a method. We're saying you have to have that behavior. If you're implementing all these things, you have to have that behavior and you have to declare what it is, but we're not going to define it here. All right? Okay. So that is abstract classes. That part is done. All right, if we go back to our class diagram, we've done this part, we've done this part. We haven't done this part yet, but that's fine. We can do that part later. I'm going to have a little look at interfaces. All right, so these ones down the bottom, we're going to make a new interface, or 2 new interfaces, and we're going to see what happens. All right, so just as a quick side note, before we make these interfaces, let's just double check. So we've got device repair. Remember that we can't put those in because it has issues with that. Now, something weird's going to happen if I click run. All right, bear in mind, if I click run, all it's going to do at the moment is create me an object and then set the owner of it to be Paul. But while you're watching it, all right, bear in mind I'm not going to have any issues. Watch what happens to these icons. All right, so if I click run, There's two significant things that happened there. First one is that it got rid of my errors. That's always lovely. It's like a massage. We like that. We want it to get rid of our errors, but the colour of this one changed. So this icon now changed to be a colourless image of the same classes. So these classes here, they've got colour in them for their icon, and this one doesn't. So you might notice whatever IDE you use, it tends to change the icons of certain things. That is the icon for an abstract class. Okay. And again, we talked a little bit earlier about concrete classes, and this is a good example of it. So this is, the laptop class is a concrete class. It means that we can create an object of that class. So I can create this new instance of it, I can create this object, and that is fine. That is a concrete class because it allows me to do that. This is not a concrete class. Device is not a concrete class. That's an abstract class. All right, because I cannot create an instance of it. All right, now what I'm going to do is I'm going to create the recyclable interface. All right, so let's come back over here. I'm going to go for this one first. All right, now the trick with interfaces is to keep them small. All right, so that's what we're going to try and do here. We're going to try and keep them nice and small. So I'm going to go device repair, right click it, new Java class. All right, so I'm going to do, let's talk about naming conventions for a second. So I called it recyclable, if I've spelt that right. So I called it recyclable. Now there is this kind of industry technique that some people like to call them iRecyclables. If you call it an I, that means it's an interface. So you might see that out in industry a little bit, just because it makes it clear which ones are interfaces and which ones are not interfaces. For now, I'm going to not do that, just to show you what the difference is, all right? Because I don't want you to be getting confused with this magical I that might have appeared. But if you do see an I at the beginning, that tends to kind of signify that that particular thing is an interface in your class list, all right? Okay, so let's go recyclable. Let's make this into an interface. Now at this stage in the game, it is a concrete class because I can make a particular, I can make an instance of this. All right, but we're going to change it to be an interface. Now, actually, this is really, really easy. All right, the first thing I'm going to do is I'm going to put in the word interface instead of class. So, all right, first quick change. So I'm going to change that word class to interface. So now I've got public interface recyclable. All right, now in here, there's quite a few rules to interfaces. Now what I'm going to do is I'm going to define a method. All right, so I'm saying for this method, it's going to return an array list of strings at this stage. Now I'm going to call that is recyclable. Oh God, I can't spell today. There we go. I think that's right. I think that's right. Oh God, that's an interesting word. All right. So I've put in a method declaration here. Now I've just put array list string is recyclable. And we've got an issue that says I can't find this symbol. Well, I just need to fix the imports and then that will go away. All right. Now, what we've got here, this is looking eerily similar to my abstract method. All right, if you can remember my abstract method, if I crack over to this one, I've got abstract and then I've got a method declaration with no body. Okay, so my abstract method again did not have a body to it. If we go back over to my interface, and again that's recyclable, I've got a method here that has no body. Okay, if I try and give it a body, it's going to say, hey, interface abstract methods cannot have a body. So what this is telling us is that this method right now is an abstract method. All right, so those things are the same. So the abstract method that we had in our other class, oh, 2 seconds, let me just faff with my screen. So my abstract method that I have in my other class works the same way as this abstract method here, but notice that I've got this in an interface. I don't have this in an abstract class. Now, this bit's a little bit interesting, so I'm going to copy and paste in some comments about interfaces and then go through them with you. all right? Because there's quite a few things in terms of what we need to know about interfaces, just so that we fully understand what we are playing with here, and then we'll implement it. All right, so we've got that this is a method to achieve abstraction. Again, abstraction is a way of reducing the unnecessary details that we don't need to know. So we don't need to know the body of this particular method at this stage. We're going to define the behaviour, the implementation, the body of this. The body of it gets defined in the subclasses. It's a bit like inheritance. It's like a similar but different of inheritance. Okay, so our subclasses, this is a superclass, our subclasses are going to implement the behaviour of this. Now this method is inherently public, and right now it's abstract. So when I implement it in my subclasses, it's still going to be a public method. Alright, now if I try and give it a variable, alright, so if I did something like int x equals 7, alright, and I said, okay, this is a variable. If I hover over it, it's going to say the constant name does not follow the naming conventions. We don't really care about naming conventions just right now, but it's saying that this is a constant. Now that is super important, alright? So if you define a variable, now I'm on this point here, if you define a variable, at this stage it is a constant, and it is a static variable. It means that you don't have to create an object with it, but it means you can't change it. Now that's a big difference between inheriting things and using an interface right there. Alright, so if I have variables, it needs to be a constant, and that is a little bit rubbish. We might not want those in here. Alright, now let's talk about these methods for a second again. So I've got you can't have a constructor, so I can't make a constructor in here because you can't use this to create an object. So I can't create an instance of recyclable. So I can't have a constructor in here. Alright, now the methods that I declare, they don't have a body. We've already talked about the bodies being implemented by a subclass. If you're going to implement an interface, you need to override all of the methods in the interface, and I'll show you how to do that in a second. This next one's an interesting one. So we've got an interface can have static methods. So we know what a static method is. We know that we can have static void add, and then I can do something like 1 plus 7 or something like that, and I can do something like print that out or do what I want with that. So let's go sal 1 plus 7, there we go. I can totally do that. That is not an issue at all. So I can have a body on static methods, but this is a bit of a weird way that you're doing something. If you're chucking static methods into an interface, I would kind of pause and think about why you're putting a static method in here. It's a little bit of a weird thing to be doing, because I mean you might find a use for it. There are uses for it, but inherently this is we're programming in an object-oriented fashion. So to have a static method is in here in the interface is a little bit strange. I used the example the other day of it's like putting ketchup on a roast dinner. It's a bit weird. It's a bit weird. Some people like it. It's a bit weird. So you shouldn't really be doing this, but I mean you might find a use for it. You can have methods in a static. You can have bodies in a static method, but you know if it's a non-static, then it's not got a body to it. All right, so that is a really interesting point. All right, you can have an interface implement another interface. All right, it's like implementception there, isn't it? You can have it so that you can have lots of interfaces that implement each other and things like that. That's an interesting way of doing it, because basically what you're saying there is that the subclasses have to implement all of the methods defined in the interfaces that you give it. All right, and I'm going to show you how to implement this interface in a second. If I'm saying that this interface implements another interface, then if I then have a subclass that implements this interface, I would need to implement this interface and the other one that is implemented in here. That might be a bit confusing, but I'll talk to you more about that in a second. All right. Now, the big point of it, that is the main point, is that we're reducing dependency on the implementation specifics. All right, which means that we're making our code more reusable. All right, so again, the key here is that we're defining a behavior or a set of tightly grouped behaviors. So you don't want to make this massive. All right, so I've got my interface. We kind of know what an interface is now, hopefully. We're going to implement it and we're going to see why we are using interfaces versus anything else. So I'm going to go back to my laptop class. Now, in here, what I need to do to implement this interface, now this is how you do inheritance. And we said it's a little bit like inheritance, but we're going to use a different word. We're going to do implements. Implements, recyclable. All right. So we're saying that at the moment, this particular class implements the recyclable interface. Okay. Now, straight away we put that in, and it's going to give us an error. It's going to say, well, hey, laptop is not abstract, and it does not override the abstract method is recyclable in recyclable. All right. So what we're going to do here is we're going to go, okay, we're going to cheat, or enter, implement all abstract methods. All right. So what all that's done is it has cheekily given us this little method down the bottom. So again, it gives us this predefined behavior. And we might not want that predefined behavior at all. We might say, oh, get rid of that. Absolutely get rid of that. We're saying here that we need to return an array list of string. All right, so a string array list. And we haven't got one at the moment. So what I'm going to do is I'm going to add one in. So I'm going to call that components. All right, and we'll look again at that in a little bit. When we come down here, I'm just going to do return components. All right. So what we're saying here is that when you create a laptop class, we might have to add some methods into it. So I might cheekily in here feel like I'm going to add some more. So I might do things like make a method to get the list of components. I might make something that sets the list of components. I might make something that adds something to the list of components. So I could have a method that just says add component, and it adds something to this component list. Now, in terms of I'm not going to put this in the constructor. I don't want to put this in the constructor because I think that when you define a new laptop, you might not want to straight away give it a list of the components. So I'm not going to kind of remake this constructor at this stage because I think that's slightly strange behavior. So I might just have a method that says add component, and I might do that in a little bit. All right, nothing too stressful in that one. Now, let's go back to this interface. So we've got implements recyclable. We've got a method here. Now notice that these two look really similar. All right. So we've said that this is an abstract method, get priority rank. That is abstract from device class. So this device class is an abstract class, has got an abstract method called get priority rank. All right. It's implemented in the laptop class, which means that it's got a body. This is recyclable. Now, this is an abstract method from the recyclable interface. Okay? It's a recyclable interface. Hasn't got a body in here because we don't define it with a body in here, but in the subclass where I implement it, it has got a body. All right? And need to define the body of it. So these two things look identical, all right, in here, but the way that we define them in our superclasses is slightly different. Now you might be thinking, hang on a minute, this seems like a lot of faff for this recyclable class. Now let me show you why interfaces are super useful. I'm going to make another one, all right? So I'm going to make another one. I'm going to do another one, and I'm going to call it chargeable. Chargeable repair. All right, so again, that was just right-click, new Java class, chargeable repair. All right, so I'm going to make another one, chargeable repair. Here we go. I'm going to get rid of the comments. All right, this is an interface. I'm going to change that word class to interface. Now I'm going to define one method here. So we're going to go with Boolean is chargeable. All right, that is all I'm going to do. That's all that does. All right, so we're saying if I implement chargeable repair, it's got to define a method which is chargeable. All right, so I'm going to pop back over to my laptop class now. That was very quick. We did this one very quickly. Now the nice thing here is that you can put in as many interfaces as you want. So I could click comma and then space and then type the new one. You don't have to have a space if you don't want to have a space, but I've put one in. You can put as many interfaces in here as you like. So that's a big plus here. So we can implement as many interfaces as we like, but we can only inherit from one other class. Okay? So we can do as many interfaces as we like. Again, we're going to get the same old thing in here. I want my abstract method in there. It needs to be called chargeable. We go, yes, okay. Now, we're going to return true because every repair is chargeable. Yes, and we might change that later on. We might change that to have something like a variable up here, which I can change to be chargeable or not. We're going to say everything's chargeable at the moment. So we've got this method now, and I've defined the behaviour of it in here. All right. Now, what I've got is I've got two interfaces. So I've got recyclable and chargeable repair, and I'm saying this particular class implements these two interfaces. Now, the reason that this is super useful is because now what we're saying is that if a class implements a certain interface, as the developer, we know that it is going to have to implement the method that is in the interface. So if I create a new laptop device now, I know that I can call a method is chargeable, and it will give me whether that particular thing is chargeable or not. So I'm giving it behaviours. I'm adding in additional behaviours for this particular class without enforcing the fact that you have to inherit loads of different variables or different methods. All right. If I said to this subclass that it had to have all of these methods and made them all abstract, that's a lot of methods to inherit, and it might mean that when I get to the inheriting them in this class, it might mean that some of those particular methods are not particularly valid anymore. It might mean that I'm misusing them slightly. For example, I might go, oh, this particular device doesn't have an owner, so I'm going to set it to be null, or I'm going to set it to be empty, and that's kind of dangerous behaviour. If you're going to make something like an object, you want it to have only the behaviours that you want it to have, not the ones that you're forcing it to have because it might not be relevant. Okay. Now, before we leave, just another cheeky note. If I click run again, have a little look at my icons. If I click run again, all it's going to do is create me a laptop device here. Two of my icons have changed. So the ones that were interfaces have now changed to look like a little key. Okay, and again, every IDE is slightly different. They look slightly different, but that is the little icon that you will see to show you an interface. Okay, so to go quickly back to my little class diagram, let's just go down here. All right, so things that we've done at this stage. We have gone through abstract classes. All right, so we know what an abstract class is. We know that with an abstract class, you can't make an instance of it. We know the difference between protected, private, and public. We know what an abstract method is now. We're saying it doesn't define the behaviour of that method. In the superclass, it makes you define it in the subclasses. In terms of interfaces, the key is to keep them small. You're defining a behaviour or a set of grouped behaviours. Like, for example, add component might be in the recyclable interface. All right. If you make these massive, then you're kind of running down the same path as inheritance. You're saying implement all these behaviours and some of them may not be valid. All right. Whereas if you've only got a small set of behaviours, you're saying implement these behaviours. That way I know they're valid for this particular subclass, and I also know that they're going to be useful, and I know that then it's going to implement a behaviour that might be useful to me. For example, if I had 20 different subclasses for device, if some of them implement the recyclable interface, I know straight away that those particular devices are going to have a list of components which are recyclable. All right, so that is a little step into interfaces and abstract classes. Hopefully that was useful.